Hey guys, welcome to our very first video of Algebra 2, section 1.1, apply properties of real numbers. Make sure you take some good notes on this. Stop the video if you need it at any time to write anything down or, rewind it if you need to. So let's get going. First thing we're going to do is talk about what kind of numbers things are. The main topic here is real numbers. Everything we're doing today is a real number, or tomorrow in class is a real number. Everything that exists is a real number except for imaginary numbers, which we'll get to later in the year. But for now, everything is real. Real is broken down into two categories. One is rational, one is irrational. Irrational numbers are numbers that you cannot write as a fraction. And they're really kind of weird, though strange numbers. Are numbers like pi. Later we'll get to a number called e. Also, the famous ones are numbers that you cannot take the square root of, like square root of 2, square root of 5. Any number that you cannot take the square root of is an irrational number because, one, you can't write it as a fraction. Two, it is a decimal that never repeats and also never terminates or stops. It just keeps on going forever. So if irrational are numbers that you cannot write as a fraction, rationals are. So rationals are numbers like 2/3, 5, 6, even numbers like 7, because 7, you could write 7/1 or 14/2. You can write that as a fraction. So those are all rational. Rational can get broken down even further into integers. Integers can be negative or positive, like -3, -2, -1. 0 is an integer, 1, 2, and it keeps on going both directions forever. Notice what's not included in integers. There's no fractions or decimals included in the category of integers, so no fractions or decimals. Integers can be broken down even further. Whole numbers are integers that do not include the negatives, so 0, 1, 2, 3, and it keeps going forever. So everything is real for now. Rational, irrational. Remember, rational you can write as a fraction, irrational you cannot. Integers, rational numbers including negative numbers that are not fractions or decimals, and then whole numbers beginning at 0 and increasing forever. The first thing I'm going to have you do today is they're going to have you graph numbers on a number line just to make sure you know kind of where they go. The first number, there's -0.2. That is on the way to -1, so it'll be about right there. 7/10 is almost 1. Square root of 2, if you punch that in your calculator, which you will need your graphing calculator, is about 1.7, or 1.2 rather, about right there. -4 is way over here. And so the first part of your assignment tomorrow, that's pretty much what you're doing. And also, if you look at number 2, it talks about which list goes from least to greatest, or increasing order. If I look at this first list, notice all the lists have the same numbers in them. So what I'm going to do is look at this first list and see if I can find what's the smallest number in the list. And looking at that, it's -2. And the way you can tell is when you look at negative numbers, think about their absolute value and which one is the furthest away from 0. And -2 is. So I'm looking for something that starts with -2. Looks like C is the only choice where that is true. So I'm going to look at the rest of the list. -3/4 is next. That's good. -1/2, good. Then it goes +1.5. The square root of 7 is 2 point something. So that's perfect. So it would be C. Also, today we're going to work on some properties, and you've seen these properties before, but we'll review them for you in class tomorrow and on the video today. First of all, it says everything is real, remember. The closure property just says if you add two real numbers, you get another real number. If you multiply two real numbers, you get another real number. That's pretty obvious, I think. The second property, commutative, probably the most mispronounced property in at least Tennessee. People want to say commutative. There's no N in the word. It's commutative. And it just says the order doesn't matter. It doesn't matter what order you add numbers in. 3 + 7, 7 + 3, same thing. It also works with multiplication. It does not work with subtraction or division. Order does matter there, but with the addition and multiplication does not matter. All these properties are true with addition and multiplication. The associative property says you can group things. If everything is added together, it doesn't matter how you group them or which two you add first. You're going to get the same result. Same thing with multiplication. You can group your factors either any way, and it will not make a difference. The identity property, additive identity is when you add 0, and the way I remember it is we started with A right here. We started with an A. We had a 0, end with an A. Start with an A, end with an A. So the multiplicative identity would not be multiplying by 0, it would be multiplying by 1, because if you multiply by 1, the A remains A, the A remains A. The inverse property, inverse is a fancy word for opposite. So in addition, when you add opposites together, you're going to get 0. Multiplication is, you don't multiply opposites, you multiply reciprocals. So multiplicative inverse is another word for reciprocal. Fancy word for reciprocal. Multiply reciprocals. The distributive property is probably the one you use the most in Algebra 1. If you have a number outside of a grouping symbol, you take the number and you multiply it by everything inside the grouping symbol. And then use the operation that is there, use the plus sign. So, and it doesn't matter if the number outside is in the front or the back. So the next set, we're just going to name the properties here of what's illustrated. Looking at this one, the only thing that changed on number 3 was what was grouped together. So that's associative. So we just say it's associative property. Number 4, they add a 0. The 15 remains 15, so that's an identity. They may want you to write multiplicative identity. Number 5, the 4 is outside the parentheses. If you look what they did, they multiplied it by everything inside. That's distributive. Excuse the handwriting there. And number 6, multiplied by 1, so the 500 stayed 500. That is also identity, but it's the multiplicative identity instead of the additive identity. We're going to save 7 and 8 for in class tomorrow. Show you one of those then. Congratulations, making it through your very first video of the real Algebra 2. And also answer the question at the end of this video, and you're good. See you tomorrow.